Chen is considering installing solar panels at his home. He wants to estimate the area of solar panels that he will need. And he found this information on the internet. Right? Let's answer part A and part B first because that is the easy part. A games console has a power rating of 165 watt. Find the amount of energy in kilowatt hours used in 5 hours by the games console. What is kilowatt? They tell you that 1 kilowatt is 1000 watt. So 165 watt will be equal to what? 0.165 kilowatt. So what exactly is kilowatt hours? A lot of students went to divide because you are so used to what? Things like km per hour, right? But if you want to divide, what must be present? You need the slash line there, right? There is no slash line. So if there is no slash line, what are we doing? We are multiplying, not divide. That is all the question is asking you to do. So the amount of energy is just equal to 0.165 kilowatt times 5 hours to give you 0.825 kilowatt hours. If you take physics and you don't know this, lucky you are attending online. This is your practice. This is your practical electricity, right? You have an entire chapter on this, right? If you take physics and you don't know this, don't tell me. You literally have an entire chapter on this topic. Next, assuming all months have an equal number of days, calculate the average daily peak sunlight hours in Singapore over the 12-month period. Now, the one thing I want to point your attention to is that this question asking you to find average is 2 marks. It is 2 marks, not 1 mark. What does that tell you? Congratulations. Cambridge wants you to write out the entire equation for finding the average. How to find the average? We need to go and find the values here. So this is 4.7. This is 4.9. This is 5.0. This is 4.7. This is 4.3. This is 4.2. 4.3 again. Then this is 4.4. Then this is 4.5. Then this is 4.4. Then we randomly have a 3.9. And lastly, 4.0. Cambridge, because it's a 2-mark question, clearly wants you to write out this entire thing. So you just go and write out the entire thing. This plus this plus this plus this plus this plus this plus this, and so on. Don't show -1 mark because this is clearly a 2-mark question, which means the method must be shown. Cambridge is so fun, isn't it? Okay, so must show because it is a 2-mark question and not a 1-mark question that you are used to. So this will give you 4 and 53 out of 120. Very nice number too. Thanks, Cambridge. Then we come to the fun part. for 7 months. Let's calculate how heavy the solar panels are so that they will collapse on Chen's house and kill him. That's what we are going to find next. Now, this graph shows the electricity used by Chen's household for the past 4 years. Find an estimate of the total area of the solar panels that Chen will need for his home and justify any decisions that you make, and showing all calculations clearly. Now, what is the first logical thing for you to establish here? There are 4 different types of solar panels. The first logical thing for you to establish is you want to go and find out which solar panel type should I use. So before you even go and calculate how much solar panel you need, right? The logical thing is I need to decide by process, right? You don't go and calculate how much you need first. You need to go and calculate, because they all have different sizes. If you have the same sizes, then not too bad. But because they all have different sizes, right? You need to go and figure out, okay, so which solar panel do I want to use first? And therefore, what is the first thing you want to find? You want to find the efficiency of the solar panel. How do we calculate the efficiency of the solar panel? It is based on the voltage, but also based on the area, right? Because you need to figure out less area means more per voltage, means if your voltage per area is higher, that means it is more efficient, right? So the first thing I want to calculate is voltage per meter squared. So for type A, what is your voltage per meter square? 300 watts divided by 1.46 meter times 1. Actually, I already put the unit on top, so I won't bother. So it's 300 divided by you need to put it as a fraction actually, because otherwise your multiplication will be in trouble. So this is 300 over 1.46 times 1.05. Which will give me, what's my voltage per meter square? So it's about 195.69 in 5SF. Then my second one, I need more space. Fractions are annoying. Second one, 370 divided by 1.96 times 1.00, which will give me 188.78. Now, when I look at this, I will directly eliminate C. Why do I straight away eliminate C? Because while you all want Chen to the house to collapse, Chen does not want his house to collapse. So I will eliminate C because it is too heavy. Make sense? So these are the kind of logical justifications that you are expected to be able to make. So the reason why a lot of students don't do well in your real-world application questions is because you all lack logic. I won't even bother calculating this. And in fact, the first thing that you obviously should have started in this case is always to start with what solar panel to use. That would have been the most logical thing to start off with. But a lot of students will go and find a whole bunch of other things one. But it doesn't make sense what? The most logical thing to start with is which solar panel am I going to use? Right? Then type D, voltage per area, so 400 divided by 1.69 times 1.05. Two 5.42 in 5 SF. And therefore, very clearly, who is the winner here? Choose. You need to say this specifically. They say justify any decisions that you make. Choose type D because it is most voltage per meter square and relatively lightweight. Right? Why must it be lightweight? You are installing on your freaking roof. You really don't want a case where your roof collapses. So this is the logical thing. So now I have chosen my type. I can now actually go and calculate how much solar panels I need. How to calculate how much solar panels I need? Now, I will assume that they want you to use the information in part B. That's why they gave you part B. So the average peak sunlight hours that you're supposed to use is 4 and 553 out of 120. By the way, for this part, I forgot to mention, I will accept obviously for 3SF. If you have 3SF, then it's 4.44, I think. But for calculation purposes, you should use the exact value. Now, how to calculate? They tell you that you need to take the average amount of electricity. You need to find the average amount of electricity used in kilowatt hours in 1 day. Right? So that's the next thing that we need to go and find. We need to find the average amount of electricity that he uses per day. You must also state what assumptions you make about the question. Now, what do we know here? If I ask you a logic question, which usage will you take? Will you take year 1, year 2, year 3, or year 4? Or will you take the highest one or the lowest one, or will you take the average, or which one? What will you take, Elijah?
The highest.
Why will you take the highest? Justify.
Because that means wait, like if you take the highest, that means on average it should be lower, and then you don't need, like, to be safe, you show that if it can, like, if the highest is okay, then the lowest also can, right?
Exactly. So at least, even though you don't take physics, you are logical. You will always take the highest amount. Why? You are installing freaking electricity in your house. You take the average amount. What if you use higher than the average? Then your house got no electricity. Is that what you want? Cannot be what? There are many students go and find the average of the 4 years. So what? You take the average of the 4 years, so you use higher than the average, then your house got no electricity because you stupid, don't know how to plan. So you will always take the highest to make sure that if it meets the highest requirement, then anything below will also work. Right? So assume usage yearly at about 3,000 kilowatt hours and 365 hours, 365 hours, my head, 365 days per year. You need to assume that it's 365 days per year because there are years with more than 365 days. And that is an assumption that you need to make. Okay? So if you know that it's kilowatts a year, what do they want you to find? They want you to find in kilowatt hours in 1 day. So what is your daily kilowatt hours usage? 3,000 divided by 365. You will get about 8 and 16 out of 73. I will always put the answers. I will always put the answers in fraction because it's more accurate. So we have chosen the solar panel type. I know how much is my usage per day already. Then now what do I need? The next part that they want me to find is what? The number of peak sunlight hours you receive each day. We already found that in part B. So in part B, the answer given to us is 4 and 53 out of 120. So this part was already found in part B. We got 4 and 53 out of 120 hours. So we don't need to find. Then next part, we need to find the solar panel output in daily watt hours, which is equal to your voltage of solar panel multiplied by your peak sunlight hours multiplied by 75%. It will always multiply by a certain percentage one because there is no way that you can. There is no way you can convert every single amount of sunlight. There is a limit to how efficient your solar panels can be. And my thing is lagging like nobody's business again. That's why I'm waiting. Now, the one thing that many students miss out is this. This is in daily watt hours, but we found our answer just now in kilowatt hours. So later on, you need to go and do the conversion. Okay. So next, we need to find our solar panel output, right? So daily kilowatt usage is equal to this kilowatt a day, right? So maybe I should not use daily kilowatt usage. I should say daily electricity usage. Okay, actually, never mind. I just call it daily usage. Because I need to change my kilowatt hour into I'm lagging so badly that my iPad decided, you know what? So kilowatt hours here, you need to go and multiply by 1,000 to know that this is about 8,219 and 13 out of 73 watt hours only. Why is my Wi-Fi so bad today? I don't know. Okay. So now I can go and calculate my solar panel output. So solar panel output given is your voltage, which we are using type D, so the voltage is 400 watts, multiplied by your peak sunlight hours, which is 4 and 53 out of 120 hours, to give me, sorry, you need to multiply by 75%. And that will give me 1332.5 watt hours. So one panel has an output of 1332.5, but my daily usage is 8,219, 13 out of 73. And therefore, the number of panels needed is equal to 8,219, 13 out of 73 divided by 1332.5. So your real-world application question is just about processing the information given to you in a logical manner. Now, but the question that you need to ask yourself, right? So I need 6.19 panels. Can I use 6.19 panels? Obviously not, right? Therefore, Chen will need how many panels? Obviously, you don't round down in this case. Round down is the same problem. You round down, then your electricity use too much, then your house blackout. Why? Because you dumb. You round down instead of rounding up. This is why you learn math, so that you don't make this kind of mistake. So Chen needs 7 panels. Right? And since he needs 7 panels, therefore, the estimated area of 7 panels of type D is 7 times 1.69 times 1.05, which will give me 12.4215 meters squared. This is the exact value, so you should not go and round it out. Done. Such an easy 7 marks. Even with my explanation, it only took me how long? It took me about 20 minutes only. Without having to explain and showing you all these things, it will probably take me like 10 minutes or less. For a 7 mark question, perfectly worth it. Perfectly on time. Okay, but you see that this question beyond math is testing you on logic. Your real-world application question is not just about math, it's always about logic as well. All right, and you need to make sure you work through the information that the question gives you systematically, and you process the parts of the question part by part systematically, like what I'm doing here. I don't try to just at one shot try to find many things at one time. I could do it in a systematic manner and ask myself, okay, what do I want? And you notice that I follow the flow chart that's given to me, right? I decide on which solar panel to use first. Then after that, I follow the flow chart that is given here to find step by step what I need to find. Just follow the process. Okay. I do think that for this particular question, this is the correct answer. Real-world application questions like the 2024 one definitely got a whole range of answers one, depending on your justifications. But I feel like this particular question only has one acceptable answer. It has to be 7 panels and it has to be type D. And therefore, that will give you a fixed answer. So if you use a different type, I don't see how you can justify using a different type. If you didn't have 7 panels, I don't see why you can have fewer than 7 panels or more than 7 panels, because 6.1 is very close. It's not very near 7 at all. So I do think that this question has a fixed answer.